giving talks to do is essentially, talk about what you have and what you want or need. And the idea will be, we hope, that we'll be able to match up needs and wants with the haves, or match up the haves and the have-nots. And so here's an example, next slide, of where we are from the discovery standpoint. So for instance, we know we need to do something better about the provenance of these relationships, but I don't think we have any really good ideas on how to do that in a sustainable, scalable fashion. We're having trouble with identifiers for things other than data sets. Data sets have DOIs, which are great, but what does an application have as its unique identifier, or a research topic as an identifier? Of course, we always need more knowledge. We'd like to find more applications in real life. And by applications, I don't mean like Firefox, I mean like flood monitoring. And then we're also continuing to look for more use cases in real life. Our last iteration of use cases focused mostly on hypothetical or sort of use case classes. And now what we're looking for are actual use case instances in real life. So that's where what we have are the theoretical ones. We have a usage-based discovery tool, which we'd like to test against those use cases. We've got some data sets, we've got some applications, and like I said, we do have a graph database. That might be it for me. Next slide. Right, so I'm going to save this for the last activity, when we'll talk a little bit about how we might collaborate. And let's go to our first lightning talk.
Great, let me just switch screens so I can pull up Cindy's slides.
So our first lightning talk is going to be from Cindy Hall, working for NASA headquarters, I think it is, Cindy, on Earth Science Data Pathfinders, which has really been a great source of applications and relationships between applications and data for the interns. In fact, it's been the most profitable source that we've found so far. So I asked Cindy to come in and talk a little bit more about those Pathfinders.
Great, thank you. Thanks for having me. So I'm with the Earth Science Data Systems Program, and on our website, we actually have a new tagline. It says open access for open science. And open data is the foundation of our program, whose mission is accelerating scientific advancement for societal benefit. And if you'll go to the next slide, please. And while the data from NASA are freely available and there are multiple entry points to the data, as you can see on the left, the sheer number of possible data sets for any given measurement can be overwhelming to a novice data user. For example, in the top right, you can see there's over 7,000 data collections in Earth Data Search, and even filtering to Veer sea surface temperature, you still have 48 matching collections. Next slide. And with regards to this, a few of our goals specifically to the content development team or communications team we've been assigned to develop new communication methods that improve findability and discoverability of NASA's Earth Science data collections, emphasize the importance of open science to NASA, and increase the awareness of NASA's Earth Science data to new and existing data users through expanded outreach, engagement, and partnerships. Next slide. So to help address some of the reported challenges with dataset selection, access, and application, and also help meet our goals, the Earth Science Data Systems Program has developed thematic data pathfinders. And pathfinders provide details on spatial and temporal resolution for the measurements that are found within the pathfinder, direct links to commonly used data sets, and information on tools for visualization and analysis. And we have data pathfinders on topics such as agriculture and water resources, biological diversity, a series of disaster ones, including earthquakes and volcanoes, extreme heat. We have health and air quality, sea level change, and the list kind of goes on. You can see all of those represented here. We also have a GIS data pathfinder, which points users to NASA's GIS-ready data sets and tools from some of our distributed active archive centers, or DACs, that help transform data into a more GIS-friendly format. And as the community coordinator for the program, I've been working closely with NASA's Applied Sciences program areas to become more familiar with applications-based user communities, how they're using NASA data, and what their challenges and needs are with regards to remote sensing data. And this information has been integral in generation of the data pathfinders. And so this applications or usage-based pathfinders, I guess, is what we have to offer. Next slide, please.
Les voy a mostrar mi línea de tiempo.
Through surveys of data users, knowing which data set to select is a challenge. So within each Pathfinder, we developed an About the Data section, which provides information that help the novice data user determine which data set might be best for their research. So we provide just right up front the measurement taken and the satellite or platform, the instrument or sensor, and the spatial and temporal resolution for that measurement. Next slide. And with the Pathfinders, we do not want to provide links to all data set collections for a given measurement, but rather just those that are commonly used for a specific use case. And in Earth Data Search, again, if you filter for sea surface temperature, you get around 1,500 data collections. But as you can see on the right, in the Pathfinder, we're only linking to 4 data set collections. And each Pathfinder is reviewed by both applied science users and DAC representatives to help ensure that the data sets are indeed some of the most commonly used for any given area of study. And they also help ensure that the information is accurate and the relevant tools for visualization and analysis are highlighted. Next slide. The data pathfinders, however, are manually generated. And this is a very tedious process as the number of data pathfinders grows. The complexities of keeping them up to date requires us to come up with novel solutions for their maintenance, and that's probably our biggest need. We're looking into the automated generation of certain components like that About the Data section mentioned above. In addition, many of the measurements like precipitation are found within several pathfinders. So for example, you'll have precipitation in floods, cyclones, water resources. And currently, if something changes, like say a new version of a data set is released, each Pathfinder has to be modified. And so we're looking at generating snippets for each measurement that can be used in the automated generation of a Pathfinder. And then with this automation, we could even do a build your own Pathfinder with measurements specified by the user. In addition, we're always looking for new ideas for use cases. The use cases you all are discussing can be used to help us determine what would be most beneficial for users when we're generating these Pathfinders. For example, we're considering development of Pathfinders that are even more use specific. So like, how can NASA data be used to meet a specific sustainable development goal? Or how NASA data are being used to measure how human behaviors or natural hazards have an impact on urban nightlight. So really kind of honing in and focusing. Next slide. So the Earth Science Data Systems program is excited to be here and looking forward to learning more from this community and providing more usage-based discovery of data. So thank you.
Awesome, thank you so much.
Thanks, Cindy. That was great. I think I want to keep going to keep the momentum, and then we'll get into the interaction part when we get to the first exercise.
Okay. Next up then will be Mark Parsons. Mark, are you here?
Yep. Sorry, I didn't send you my slides. I didn't realize I was supposed to, but I will share my screen if I am allowed. Trying. Oh dear.
All right.
My whole slide. Oh, there we go. Do y'all see it?
Yes, we can.
Perfect. Looks good.
Okay, so first off, some apologies. I was involved with the reboot of this group in the very early months, and then I dropped out. But I've recently started a new job at the University of Alabama in Huntsville, basically working for NASA, working with Peter Fox and Ruth Durr and Kaylin Bugby and lots of characters you all know, to try and facilitate discovery across all of NASA's science mission directorates. So Earth, Sun, planets, space, biophysical. So much more than Earth science, but all within one agency. So I have a renewed interest in discovery. that said, back some months ago, there was some discussion of citation and how it relates to usage-based discovery. And so I'm kind of on a mission to make sure that ESIP uses the term citation consistently throughout ESIP. So I chair the artifact citation cluster where we figure out how to cite everything. ESIP, as I hope you all know, has some pretty well recognized data citation guidelines that were just updated a little over a year ago. And in those guidelines, we adopt this definition that comes from CODATA, that data citation is a reference to data for the purpose of credit attribution and facilitation of access to the data. So referencing, getting to the precise thing that you're talking about. Access, meaning, sort of the location of that thing, how you can get to it, how you can get it or go to it. And then the credit one, which is the most complex. It's because it's extremely contextual, but often really important because it can inform, sort of the authority behind the data, the provenance of the data, what peer acceptance it has, and so forth. And then citation has other purposes, implied purposes as well, such as, may imply some level of authority, and may imply some level of permanence, may be used to measure impact or track provenance. But does it aid discovery? So that's kind of what I want to ask. So first, I want to make sure that you all understand when you're talking about citation that you mean all these things: reference, credit, and access. And then how does it relate to discovery? So it's interesting, when ESIP was first developing its data citation guidelines more than a decade ago, we laid out various purposes, and discovery was not one of them. It helps with discovery, but that's not necessarily the purpose of citation. All these things that are included in a citation, like the publisher and the author, might help with discovery. Those might be things that you want to search on, but the primary purpose of citation is not necessarily discovery as such. And I just double checked again today, the Joint Declaration of Data Citation Principles doesn't say anything about discovery. It says things about identification and access, all things that are related to discovery, but not discovery as such. And indeed, I think when you try and do all of this, reference, credit, access, blah, 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 in a single mechanism, it may actually make discovery more constrained. So in my previous job, I was working with a group called the Deep Carbon Observatory, which has a repository that, and a mechanism for sharing data across countries and all sorts of things. And we agreed to try and adopt a couple RDA, Research Data Alliance recommendations around data citation. And one of them is called Scholix. And it's a way to better interconnect journals and data, articles and data. So, ideally the articles cite the data, but wouldn't it be nice if the data also knew which articles referred to it? So this was a way to try and establish sort of that street. And they constrained it very specifically and very deliberately to that two-way street between articles and data. And they very logically built off existing registries, hubs, networks that exist, such as DataCite and Crossref and OpenAir, because a lot of repositories were working with those different hubs. So the idea was that, if your data were registered in DataCite, you wouldn't have to worry about this. It would magically happen. As we got into this project, we didn't, first off, I should have mentioned at the beginning that Deep Carbon Observatory does not use DOIs for their data. They use handles, which is a perfectly acceptable persistent identifier, but it's not the one that's typically used in the scholarly communication community, which is pretty devoted to DOIs, with a lot of exceptions. But and so for us, it was not easy to just connect into these registries, and because that's not the way that that system worked. And so I guess my takeaway from all of this is, my sense is that the discovery cluster is going in the right direction, that we need to be thinking about a much more open sort of web-based approach to discovery. And especially with earth science data, where usage occurs, much more important usage occurs outside of the scholarly communication infrastructure. You know, this is very much geared towards the scholarly communication infrastructure. And so when we talk about citation as a mechanism for discovery, let's just think about that one little piece of citation, the reference piece. The specific thing that you're looking for, and maybe and some hint of how to get to it. And that doesn't mean that you don't play in this space. That doesn't mean that data shouldn't be formally cited. That doesn't mean that data should not reference the literature it comes from. But working in this is not going to necessarily improve the discoverability of your data, is my conclusion. And so then maybe we knew what we were talking about 10, 12, 13 years ago when we were first conceiving of the notion of data citation. So it was meant to be a little bit provocative. It was meant to be a little bit educational. But my main takeaway is keep the definition in mind. Thank you.
All right, thanks a lot, Mark. That does give us a lot to think about.
How do I turn off my sharing?
Okay,
Great, thank
and
you.
next we're going to hear from the air quality cluster. Beth or Mike, which one of you are planning to talk?
You're stuck with me, Chris.
All right, Mike,
Beth
go
is
ahead.
welcome to jump in, but I'll go ahead and try and work through the slides. So 6 minutes, no hot air, I promise. If you believe that, I have a bridge to sell you. Next slide, please. The air quality cluster is motivated by the fact that air quality affects all of us. In some areas, it's even more impactful than a lot of the other features of the environment. And that's the reason that there are air quality sensors on the roof of the US Embassy in Beijing. But the air quality community, the end users of air quality data and tools and models are pretty diverse. There's a considerable number of research scientists who are doing work in air quality and understanding the state of air quality, but there's also a lot of end users, parents with kids who have health problems that air quality directly affects, like asthma. And so we're trying to understand how best to satisfy the needs of all those different communities. And so one of our efforts was to try and partner with the Discover cluster to try and use some common tools that maybe the Discover cluster was developing that might help those end users identify the data in a more effective way that they might be able to use. I would mention that we're not just interested in the data, but we're also interested in the tools and the model output and those kinds of things. We're also using the AQ cluster to address the integration of data from lots of different sources, including in situ sensors, as well as remote sensing data, data from a variety of agencies and private institutions, and tools and models as well from all those different sources. So one of the hallmarks of the air quality problem is that we're using data from other sources besides NASA. So next slide, please. So our objective inside of the ESIP air quality cluster is to develop an AQ resource center that helps lots of different people find the things that they need to help them. And so that would include data and tools, models, and so on, visualizations, alert capabilities and a pretty wide range of things that we'd like to help them be able to track down and use. So we have essentially really two major activities that are going on right now. One of those is development of a set of use cases, and we used our ESIP meeting, our ESIP Winter 2021 meeting earlier this week to start developing a set of use cases that come from a pretty wide range of sources, including the research community, but also the people with practical problems that need to be solved. We're also trying to develop a catalog of air quality data sources, and that's where we really think that that we can get some help from the discovery cluster for trying to do that. That would be broader than perhaps some of the things that are going on right now that we've already heard about, to include sources that are not NASA sources in particular. And then we expect that we're going to use a hackathon during the summer ESIP meeting to try and address construction of that resource center. Next slide, please. So the things that we have, I think we're in a kind of catch-22 here. The things that we have are user profiles and use cases, and that we're trying to develop this catalog, as I said before, of data, tools, and services. And the things that we could help the discovery cluster with is potentially a resource center with more resources than normally are available just outside of the remote sensing data, and information about those resources, and then use cases to help develop specific discovery problems that maybe are not otherwise picked up. AQ, like I said, has some unique situations. So the timeline that we have mostly runs out until the summer meeting, and we're going to be using our monthly meetings, which are on Thursday afternoon, late in the afternoon. I think it's the fourth Thursday in the month, to continue filling out those use cases and the profiles, and to begin to identify what we want to put in the discovery function that we're going to try and perform. And I think that's my last slide.
Yes.
Back to you, Chris.
Okay, that was cool. That looks really useful. The next talk is going to be by Rupa Gupta, who with Jonathan Blythe is representing the Community Resilience Cluster.
Thanks, Chris. Hi, everyone. I'm Rupa Gupta from the Community Resilience Cluster. My colleague, Jonathan Blythe, is also here on this call. I'm sharing a little bit about some of our recent work, as we've been working on a problem statement that we felt may be of interest to other clusters as well. What I'm sharing today is a subset of sorts of what we shared in a workshop session yesterday and received some really great feedback. So looking forward to sharing with you all as well. Next slide, please. So the goal of our Community Resilience Cluster is to really think about ways to enhance community resilience through what we think of as culturally relevant improvements to data access and data visualization. In other words, how can data access and data visualization be refined to more effectively meet the needs of users, especially in communities, to create solutions for environmental issues, resilience issues that happen there. Next slide, please. So our problem statement begins by acknowledging that historically Earth science data has been made by and has been created for scientists, so that data resides within a silo of sorts. But recently there has been more interest in accessing that information from beyond the scientific community, with the acknowledgement that there is value in this data and information, especially to benefit social causes, environmental causes, and advancing community resilience. And in this framework, we think about resilience as a means to guide how communities make decisions to improve their lives and address environmental challenges while coping with risks that they may encounter. And specifically, resilience becomes a multi-layered thing. It could be at the infrastructure level, it could be at the community level, individual level, family level. So, there are multiple levels of community resilience that could be impacted. So our big question we ask in our problem statement is, how can earth science data be used to more effectively enhance community resilience? Next slide, please. And we went about it by first taking a big step back and identifying the challenges that exist in the field, and then crafting some recommendations or resolutions for it. But today, I'm going to be focusing on one of the 4 challenges we've come up with. As you can see, they are related: inequity in the scientific process, the issue of data ethics and governance, the scale and focus of data, and finally, data needs of users, which I'm going to be focusing on more today. Next slide, please. So when we think about data needs of users, data literacy has been the lens through which data use has pretty much been examined. And even though there are many, many definitions of data literacy, there's a limited attention to what this concept actually means for communities. So essentially, we know very little about what motivates community residents to want to or not want to access data. And data literacy may actually look very different for specific members of communities. Some may want to use the data to make sense of and tell stories with it. Others may need skills to interpret data. And yet others may want to take on the role of scientists and want to use more technical data. So this nuanced understanding of data needs is currently missing. And part of the problem is a related challenge that historically there has been limited interaction between scientists and decision makers. And so as a result, a deeper understanding of a community's priorities and worldviews that relates to their data needs is lacking. Next slide. Then the application of earth science data for problem solving for societal benefit is often thought of as a data, information, knowledge, and wisdom pathway. And the climate change discourse actually offers a good example of this, where earth scientists observe trends, they compile the data to describe climate change patterns, then technical information about climate change is shared broadly, and then knowledge of climate change grows across disciplines and into the public. And finally, climate change becomes central to decision making and the applications for social and environmental benefit. This process, however, is typically thought of as a linear mechanism, which leads with data and information. And this overlooks the complexity and nuance in engaging the public. And the public in this scenario becomes passive recipients of the information. So this exchange within the various aspects of the DIKW pathway is not understood as well. And it neglects the interactions between scientists and community members who may have very different needs. So as a result, when we think about relevant data access and data visualization about climate change, for example, we need to acknowledge the cultural context of the communities who would presumably be using this. Next slide, please. And so in the spirit of collaboration, thinking about how our cluster could learn from and contribute to the discovery cluster's work, and maybe even other clusters work here, we sort of came up with some ideas for how to do that. What the discovery cluster could help us with is to identify scalable solutions for free and relevant access and visualization of earth science data. And also we we would also love solutions that aren't necessarily stovepiped by funding agency or sector, so that they can be shared and accessed broadly. And on the flip side, what we can contribute to the Discovery Cluster and others, I hope, is to provide expertise in community engagement and rigorous human subjects research, and also information on the Evidence Act to guide ESIP's response to statutory requirements. Next slide. And with that, I come to the end of my talk, and I really look forward to conversations and your thoughts on what you heard from our cluster. I'm going to have to drop off very soon, but my colleague Jonathan is here, and he's going to sort of represent our cluster moving into the discussion. Thank you.
All right, thank you very much, Rupu. That was very good. Next talk is going to be given by Dave Jones, who with Karen Moe is representing the Disasters Lifecycle Cluster.
Thanks, Chris. Yeah, Karen is also on the line here, and we basically put together the poster that we're going to be presenting tonight as well. But we wanted to give you a little overview of the Disaster Lifecycle Cluster and some of the things that we've been doing. And just to give you an example of particular use cases, because that's where we're driven by. We're driven by use cases in the field, working with organizations like the All Hazards Consortium, who is connected to transportation, food, fuel, utility, and medical supply sectors across the country, and enabling safe transportation and response to disasters, like from the utilities when they put out mutual assistance and need to restore power in large areas like hurricane landfall. So what you see on the screen here is an example of accessing multiple federal data sets to support a single mission during one of the California wildfires last year. This was the August Fire Complex. And what you see outlined in red, those boxes outlined in red, are actual FAA flight restrictions that were placed around the fire location, which means you can only fly at 12,500 feet. Those yellow dots that you see in there are actual imaging task orders from the California National Guard to the California Civil Air Patrol. They're basically saying, we need you to fly into this area and get pictures of these locations because the wildfires have damaged these structures. And so this is basically their task order. And what you see in the colorful part, the yellows and reds and purples, is NOAA's high resolution rapid refresh smoke model that was running in the experimental phase, but now it's been transitioned to operations within NOAA. And this data set is showing hourly forecasts of where the smoke is likely to be. So in one collaborative common operating picture, we're leveraging multiple federal government data sets and giving the Civil Air Patrol an opportunity to swoop in when the winds shift, to get some of those task order images collected, and then get those back to the California National Guard. So the ESIP disaster lifecycle lives where the rubber meets the road. We work with decision makers all the time, and we're looking to reach back into ESIP, which is part of our plan over the next 6 to 12 months, to leverage what's happening within clusters so we can put more data to work. Next slide, please. And I want to acknowledge Sean Huang, who's also our ESIP fellow, supporting us in the disaster lifecycle cluster as well. So this is our poster. The big idea is, how can we collaborate with ESIP clusters and activities to really deliver results? We have a technology in place now where we can take data sets and put them in front of decision makers to give us feedback on the value of those data sets. This has been years in the making. It's been a lot of relationship building and a lot of opportunities dealing with utilities and other sectors and their emergency management responders. The ESIP acceleration part comes right where we have the discovery cluster, drone cluster, air quality cluster, community resilience cluster. And so how can we accelerate the great work that's being done there and deliver it through that tip of the spear approach right into these use cases where decision makers live. So some of the operational application areas include inundation modeling. You can hit the next button. There's just some connection lines happening between clusters here. Inundation modeling for transportation. You know, what roads are going to be flooded when you have 100 bucket trucks responding to a disaster. There's nothing worse than watching 100 bucket trucks with copper wire on the back of them trying to turn around on a road that's flooded. They end up damaging, you know, tens, if not, 50 properties trying to turn around. Soil conditions for debris flow forecasts. Whenever there's a wildfire, it changes the hydrophobicity of soils. How can we get that remote sensing put to work so we can give the National Weather Service a better read on the soil conditions so they can adjust their flash flood guidance for debris flows? Air quality cluster, perhaps wildfire response and air quality. Certainly the HER smoke model is great. They're also able to model PM 2.5. How can we get air quality measurements out to the public and out to decision makers so the responders know what kind of air quality they're going to have when they respond? Also planning for agricultural climate change. We have big changes that have been happening and are on the way. So how can we put the agricultural and climate cluster together so we can leverage some of their projects and put that in front of some decision makers? And so the next slide is the last slide, but what we're looking to do is to build this ESIP ecosystem of innovation. We all have the things that we're working on. We all want to put our data to use. That's the mantra of ESIP. So as an example of these clusters on the left-hand side, you have discovery, drone, and community resilience, but it could be a lot of the clusters that ESIP has. Of course, we're in the data discovery or the discovery cluster. So that's going to be critical. How can we discover what's going on? What data sets in REST service formats, in feature services, can we get access to quickly to put into the disaster lifecycle cluster and then feed that out into the All Hazards Consortium, NOAA, DHS, and CISA, the Cybersecurity and Infrastructure Security Agency, into the state of Florida with the new project that we have going on, and also through the National Weather Service. And there are other application areas that are just waiting in the wings. So how can we take these efforts that are going on within the clusters? I think Discovery Cluster is a critical one because we need to have decision makers to type in wildfire and then have feature services show up and REST services show up or KMLs show up that can lead to helping decision makers not only access the data, but trust it. So in the bottom of our poster, you may have noticed the 1, 2, 3 ORL levels. They're the operational readiness levels. So we worked with the All Hazards Consortium and ESIP to come up with operational readiness levels for data so decision makers can trust those data sets right away. They don't have to question them. They don't have to go back and research them. They have these ORL numbers associated with them, and then they can go off and make their $1 million decisions because this data is trusted. So we're really looking to establish the real world, real world efforts and applications so we can put every cluster's talents together and test in this operational environment. So that's it for now. Thanks.
All right, thank you very much, Dave. That was really good. Really a lot to think about there. Next and last talk for this set of lightning talks is going to be Brian Wee from the Ag and Climate Cluster, I believe, Brian?
Yep. Thanks for inviting us. And I'm presenting on behalf of my co-chair, Bill Ting, whom I think is on the call. So I'm going to show you a couple of experiments that we've done and I cooked up an experiment within the last 1 or 2 weeks, specifically for the context of this talk. Next slide, please. So how this all started was the Ag and Climate Cluster. We started thinking about issues around traceability about more than a year ago. Like, how do you connect data to models to publications, and from publications to scientific assessments that affect decisions and policy. And the areas that we focused on are mostly on climate adaptation for agriculture adapted applications. And that had a history in and of itself, because we were working with NOAA's climate resilience toolkit, the CRT, for some time. And so that it kind of influenced our thinking about, trying to trace the story of how data is eventually transformed into information for policymaking, harking back to Rupu's earlier talk about DIKW, right? So this started with two ESIP projects. One is a decision provenance ESIP lab project, and what I'm going to show you is I actually use code, a bit of Python code developed using that ESIP lab project, essentially to read in documents, text documents, to look for terms that are curated in ontologies. Again, that's coming up. And we have another current project in which we're using a Neo4j database, a graph database, to connect entities in bird conservation planning. So what I'm talking about here is, in bird conservation planning, we have various organizations. Each of the organizations have different kinds of plans, and each of the plans target different bird species over different geographies. So how do you tie all those elements together? So we have been modeling all these different entities in a graph database, tying the connections together and designing the queries. So the queries to the Neo4j database are conducted in this query language called Cypher. So if you're familiar with SQL, structured query language, it's very similar to SQL, where we have been developing the queries to in order so that we can answer specific questions posed to the graph database by using a query. Now, what we did was, using these two past projects, the decision provenance and the connecting entities to bird conservation planning, we've been applying the technology developed there to two different things. One is to today's tutorial that was this morning, where we're talking about science in the US government. In that tutorial, we didn't have time to show, but what we did was to show, we took two publications, two scientific publications, and we ran these publications through the Python program, chucked the relationship between these documents and ontology terms into a Neo4j database, and we visualized the connections between publications and legislation in the US Congress. So that was actually meant for today. We didn't have time, but tomorrow, during our carbon management and informatics session, we're going to show a slightly different version of that, which I'm going to show a variant of that in the next slide. And that's my final slide. Oh, and so we can go on to the next slide. Oh, okay. Actually, that's not my next slide. That's not my last slide. So in this technology experiment that we've been doing, that you saw there with carbon management, with US government and legislation, and with the bird conservation, what we have been trying to do is, given a written problem in human language, I mean, this is not, we're assuming that it is not machine readable. It's just a bunch of text, 2 or 3 pages. Given a written problem of a domain, right? Feed that document, that human readable document, to a machine and get the machine to indicate to you what are the relevant publications that might be relevant to that problem. And further, to get the machine to indicate from those publications, trace back to what are the data products that inform those publications. Again, going back to issues about traceability. So that is the ultimate goal of what all these various experiments that we've been doing over the past few years. That's what it is ultimately aimed for. Now, the approach that we took for this demo that you will see next, and it's only a 1-slide thing, is, again, we took a text, a parser written in Python by Tom Nayrock, and we modified it. So right now, this Python program, what it does is that it ingests text documents that you feed to the program. It looks for terms in that text document, for terms defined in the BFO compliant ontologies, ENVO, food, on and agro, right? Once it finds a term that is curated in these ontologies, it writes that term out to the Neo4j database, and it says this term in this ontology is found in this document. So there's a connection, a relationship between a document and those terms. And then furthermore, we wrote, of course, the cipher query that will retrieve the relationship between documents and ontology terms. And we don't have time to go through it here, but if you're curious, that is the cipher statement that returns those relationships. And could you show the last slide, Sarah? So this is the query result from Neo4j. It's a tool called Bloom. On the right, also I would describe the diagram. On the absolute left-hand side is a document that the Biden administration will use to inform its strategy about how USDA is supposed to deal with climate. It's called the Climate 21 Project USDA memo. Now, so the orange nodes that you see there are the ontology terms picked up by the Python program that were found in the Climate 21 USDA memo. The gray slides, the gray colored nodes are the publications that, again, the Python program had scanned through for ontology terms. And so, of course, what the cipher statement did was to say what are the ontology terms found in the Climate 21 memo that are also found in the publications in the gray nodes, and it's able to make those connections, and that's how it is retrieved. Now, the data product column are the pink nodes that are displayed on your kind of the middle of this figure here. Those are mostly data products from guest disk. I found those data products, and those data products in guest disk mostly like NLDAS data products. Guest disk had already established the relationship between the data products and those publications, and so that last part was hard coded. Everything else that you see on the screen was actually managed by a machine. The machine extracted the relationships, and then the machine displayed these relationships based on the cipher query. So that's all I wanted to show. Thanks.
All right, thank you very much, Brian. Very interesting stuff. Kind of paralleling a little bit of what we're doing here, I see. All right, so the next effort, and this is going to be where we really start the swap meet in earnest. We've got a Google Jamboard that has been set up. We've actually kind of pre-populated a little bit with some of what we got from your advanced copies of these slides. So thanks everyone that sent us advanced copies. But having said that, do we have the link to that Jamboard, Sarah? In the chat, maybe?
Yes, let me put that in there. It's definitely in our agenda, and I will now make sure it's in our slides.
So we've got a Google Jamboard, and it's basically stickies, and you can draw on it, right? So it's not very complicated. And the idea that we had is to basically put up this sort of things, you know, the haves and the needs, and see how many of those we can essentially connect just, you know, by drawing on that Google Jamboard. And if we don't have all the things you think we should be connecting up there, go ahead and add a sticky. Don't be afraid to write on it. That's what it's for. We're not going to lose our deposit or anything because, you know, it's just a Google Jamboard.
I will also share my screen so that you can see what we're talking about. So there are multiple panels also on this Jamboard. These are some themes or topics that Chris and I pulled out from the talks. And then ultimately what we would like is just to sort these topics into needs and haves, kind of like this. This is just an example, but let's work in this one just for a few minutes, and please feel free to add any stickies. You can do that right here. You can click on this just to add a new sticky note. You can change the colors as well. And what we'd like to do is just start to group them into categories here.
And what was the color coding we had for, was it blue for have or blue for need?
Yeah, either way, we probably want to, there also might be some instances where we have duplication or multiple needs that might also be haves for other clusters. So yeah, let's use blue for have and yellow for need on this board. And I'll also.
And if you want to make them specific to your cluster too, go ahead and modify the sticky as you need to.
Sorry, I don't really understand what's the difference between the different boards? Which one are we supposed to be playing in?
Just the first one.
Okay. But there is no color coding in that one.
Not yet. No, I think we can
Okay, so we're
go
just
in and edit
it's
the
up to
notes.
us to just decide whether a case study is a need or a have.
Right, and it could be
Okay,
both.
no,
There
yeah,
could be-
exactly. Okay, no, I'm down with it. I'm just all right. Let's go.
Sorry, I missed how to get to the Google Jamboard.
Oh yeah, there's a link to it in our chat box.
Are these categories applying to ESIP as a whole or to a cluster?
It could be either one.
How do we know which one it is?
This is all wide open, Gary. This is just like the broad universe, and we're going to go after that. That's how I'm interpreting it.
Yeah, so if you have an idea for how to narrow one down, particularly for the haves or for the needs, and particularly if it's your cluster, go ahead and modify the sticky so that it identifies that cluster. Otherwise, if it's an ESIP wide thing, go ahead and add ESIP wide to the sticky.
So we could duplicate a box and
Yeah.
subcategorize it by cluster. Okay.
Yeah, that would be fine.
Mm-hmm.
How did we get 2 graph expertise discovery stickies? I made one. Who made the other? If nobody claims it, I'm going to remove it.
Well, no, I'm working on it. So I didn't make it, but I
okay.
see that we have 2 different sources of graph expertise.
All righty.
And so that in itself should probably be a link. So it's okay to link to halves as well.
Yeah, we can actually annotate this board as well. There are some editing tools on the left, pens and markers. Or you can just stack the sticky notes as well if you want to just cluster them. Either would work.
Yeah.
And I wonder if we might actually be overloading it. I'm losing some responsiveness. And I think we probably want to keep focusing on the sorting instead of the line drawing, because I find that is difficult to do, especially with things moving around. Now I see AI plus ML that return OGC compliant services. Which cluster is that associated with? Or is that an ESIP wide thing?
Could be ESIP wide, but I put it in from disaster lifecycle.
Okay.
Chris, I typed something, but I don't know how to put a box around it and have a color.
That's okay.
Well, but then we don't get to see what Rama typed.
Was it
We all-
community
we all-
data guide?
Oh,
Was
is
it
the community guidelines for data set quality?
Yeah.
Yeah, I think the more important thing is it in the have? It's in the have column, right? Not the need column.
Well, it's sort of in the middle
Okay.
because it's
Is
in
it both
development. That's why I
columns
put it there.
Well, and that was my question, Chris. Like define designated communities, that was mine. And we have, that's definitely a need, but it's also a have. I mean, some places are, so what do we do with things that are both, I guess?
Yeah, so I would put them in both columns, but let's annotate them to the degree that we can. So when we put it in the have column, when we put a copy in the have column, list the actual designated communities that we know about. So for instance, we've seen the agricultural community, we've seen, I think there's probably a climate change resilience community or disaster resilience community.
Okay, I see what you're saying.
Yeah, so things are proliferating nicely. In fact, I think maybe we want to make a little bit more or add a little bit more specificity to some of the notes that are on there, and particularly in the have category. And I think if anybody wants to start working on the other panels, feel free to do that as well. We've got some things in panel 2, panel 3 is blank.
Panel 2 is largely set up as an example, but there might be some themes in there that we want to make sure we pull out. So feel free to take anything from that as well. And as Chris said, this panel 3 is blank. So if you want to do anything there.
Okay, and I think in a couple, wow, things are still moving pretty fast. I think in a couple minutes, what I'd like to do is basically pause and then start going through some of the more interesting and detailed needs and haves. So let's finish up in 2 or 3 minutes. And what I'm gonna concentrate on, I think, as we go through those, and we'll just spend a few minutes going through because I do want to get to the collaboration part. Is I'm gonna look at the ones with the most detail, just to kind of get a sense of what we got. Okay, pencils down. And let's start taking a little bit of a look here. So under the needs, we did mention briefly the AIML with OGC compliant services. And that sticky went up right on top of what I was going to read next. Thank you. Okay, real-time data search for decision-making use cases. This looks like another disasters lifecycle cluster one.
Yes, it is.
Okay, yeah. So that is a very specific need, and I think we would like to get there someday. I think one thing that we learned in the Hackfest over the summer is that we may want to target the sort of data wranglers and the application wranglers for the database that we're putting together more so than the actual end users. And that it would be those data wranglers that would be pulling the data and tools and services together and packaging them up essentially for whoever was actually at the tip of the spear for the disaster response. I see peer review. Are we using ontologies correctly? That's a good question. I know that in usage-based discovery, we've been kind of ontology light. For precisely that reason, we're not sure how much we want to get into the ontology aspect. And so I think we're looking for some discussion with the semantic folks to decide, how much should we get into that. Ontologies for user types, I think, would be a really useful ontology if we are going to go into something like that. And in fact, I'm going to want to come back to that when we get to the collaboration discussion. AWS cloud credits. Yep. Is that the have or the need? Okay, and let's see, what else do we have there? We mentioned briefly the community guidelines for data set quality, a processing pipeline for real-time data in response to known use, also disaster response. So I'm seeing that there's a lot of real-life use cases in the disaster response area that we could provide some help to. I don't think we can solve it ourselves in the usage-based discovery cluster. And I think we need to go to Dave's diagram, which had that whole ecosystem of clusters collaborating. And so I'm going to want to come back to that when we get to the collaboration aspect as well. Let's see, we've got contacts within communities, the community data cluster, that looks very useful too. Problem solving data in addition to ARD. Ooh, that's a really nice concept. I like that. Users defining operational readiness levels for selected data to assess trusted data. Yes, I think we need to figure out a way of providing more trust. And I think what we're seeing is that trust goes all the way through the system. It's not just the data, it's also the tools and the services, and it's even whether a given tool and a given data set can be put together safely.
Hey, Chris.
Yeah.
I would also say that it even goes down to the relationships and the relationship building that you do between the decision makers and the data providers. So, I mean, we've been working with the All Hazards Consortium for now 6 years, and now utility manager emergency responders are trusting us like they do their own people. Taken 6 years.
Yeah, I think that really is important. And I think the people side of this is becoming more and more important, even to something like usage-based discovery. And so at this point, I think I want to move over to start talking about collaboration. Sarah, could you bring up my slide deck again and go to the last slide, please?
Absolutely. Let me.
Okay, and while she does this, I'm going to tell this story, the story that throws Peter Fox under the bus. So as a long time ago, we had this cluster in ESIP called the Earth Science Collaboratory Cluster. And the idea behind that was that it would be this environment that would allow scientists to work with each other in real time or asynchronously, probably in the cloud, which was kind of new back then, and they could share data and they could share workflows and they could share algorithms, they could share basically everything, data set results. It would be a seamless environment. We kind of had the idea for all the pieces that needed to be there. And so we're out there giving talks to try to, sell it to the community and things like that. And that was going pretty well. And then I gave a talk on the Earth Science Collaboratory at AGU. And I think that it might have been after the beer break, which may have something to do with what happened then. And so after the talk, and I was talking with Peter and we were talking about what to do next. And he said, instantiate the graph. And I thought that was just brilliant. Although afterwards, I could not really figure out exactly what that meant we should be doing next. And so ultimately I didn't pick that up. And I think it's probably just as well, because back then the technologies that we had for that sort of thing were a little complicated, and they were sort of both complicated and primitive at the same time. We had, most of it was coming out of, that pure ontology community. So it was like OWL and RDF and things like that. Nowadays, we actually have a lot more technology that has made this graph aspect of relationships much more accessible. AWS has got a managed Neptune database, and Neo4j is actually a fairly easy thing to get up and running. And there's Gremlin, and there's like 4 or 5 different query languages for them, many of them easier to use than Sparkle. And so now, fast forward to where we are now, we've got a bunch of different clusters that have intersecting but not identical needs. And the traditional way, Sarah, could you go to the next slide, please? So the traditional way we usually collaborate is through these sort of intentional models where we'll have a joint cluster meeting, for instance. The problem with that is it's okay-ish if you got 2 clusters working together. But if you got multiple clusters trying to work together, it becomes pretty unwieldy. I mean, you end up kind of just in a great big meeting, or you've got this, sort of multi-linked thing. It's just unwieldy. Another way to do it is to kind of have an ambassador where you've got someone from one cluster that sits in with the other cluster. And the slightly more complicated ones, you actually exchange ambassadors, and you got someone from one cluster sitting in the other cluster and vice versa. And we kind of have that a little bit right now. So we got Jonathan Blythe, for instance, both in the community resilience cluster and also very active in the usage-based discovery cluster. And we get a lot of benefit from that. But again, I don't know how well that really scales. And so what I'm asking the community is, can we develop an emergent model where we can combine the tools and the relationships amongst us, both in the tool and in real life, to somehow make these collaborations happen a little bit more, I'm going to say, organically. The same way, for instance, that you've got relationships that happen, not always in a good way, admittedly, in Facebook and LinkedIn and things like that, and in all those social tools. Is there a way for us to marry that sort of tool-based social interaction with the real life social-based interaction, as well as putting now people into these tools, not in a creepy neuromancer sort of way, but putting essentially avatars of the people in those tools so that we can use them as well to connect all these things together. Because people are nexuses of knowledge every bit as much as you find a nexus in a graph in a database. So that's my spiel, and I'm kind of throwing it out there, I know, and I'm looking for, Peter's saying clusters do not collaborate, people do. This is true. It's the people in clusters that collaborate, which makes it even more complicated. And so Peter's suggesting multi-way, and then allow the graph of collaborations to form, and then examine the graph and find the supernodes. And this, I think, was a lesson from Malcolm Gladwell in The Tipping Point, I think it was, where you look for the mavens, for instance, that are connecting multiple people or multiple.
No, please, Chris. Don't cite Malcolm Gladwell on this, please. I'm sorry. Malcolm Gladwell is a hack. The concept is really solid. It's well established in social science.
Okay,
Malcolm
well then,
Gladwell is
raise
a
the
cherry
Malcolm
picker.
Gladwell
Don't
chart.
cite Malcolm Gladwell on this. I'm sorry, you just tricked a nerve.
Okay, would you like to follow up on the actual good part of that? And
Yes, please. I'm sorry. I didn't mean to jump down your throat. That was really mean. The point of supernodes is really critical, and that goes back to Barbarossi. I mean, this is you know, how scale-free networks work, and I think that's really critical. And bringing in cherry-picked stories of how sneakers take off doesn't actually help us very much. So that's where it just got my blood boiling. And so, but the supernodes concept and how the people that know people is are really critical. And yeah, they're Peter, thank you. And maybe Peter, maybe you can rescue me here. Sorry, I got a little excited.
And in fact, Peter has really put his finger on it, because in fact, the ESIP community fellows are designed, that whole position is really designed for this kind of thing. It's really designed for, you know, cross-cluster networking and collaboration. So we, at the same time, we don't want to put all the pressure on you ESIP fellows. It's not like you have to solve this whole problem for us, but I think you can really help us out. And I know Sarah has really been helping us out in the usage-based discovery cluster.
Hey, Chris, this is Dave. I was, you know, just listening to the conversation and just wondering if an additional way to approach this is by identifying a common thread, common goal, if you will, or a North Star to push for, that requires all the clusters to provide input. And so it's almost like a teaming of those clusters to address a specific thing, rather than everybody addressing, you know, 3, 4, 5 things at once. Is there a North Star out there that we can all put our arms around, that we can leverage our expertise to say, yeah, if we shoot for this and we solve this, we can tell the story for how the clusters contributed and the people within those clusters contributed?
So in other words, we would use a use case as the super node in that.
Right.
Yeah, I think that's a valid idea. If we could all agree on the use case.
Well, I know for the disaster lifecycle cluster, we're working with use cases and a group that works with decision makers all the time. So, you know, we could throw use cases out there. They don't have to be chosen, but they could be ones that are, you know, we're out there with people that have to make $1 million decisions. They're turning to a community saying, where can I find the data that I can trust?
Right.
It seems like we have some built-in potential.
So, okay, so let's pursue that a little further, and we'll come back to Rob Casey's comment, which is also good. So I guess what I would be looking for in that case, from the usage-based discovery cluster standpoint, is there a use case that the use case-oriented clusters could agree on? So we've got ag climate, we've got community resilience, we've got disaster life cycle. You know, is there a use case that you all would have in common that you think you could all come together on and say, hey, yeah, let's all get together and solve this use case, and we'll bring in the various, I'm going to call them the technology-based clusters, which would be the discovery cluster. It might be some of the semantic technologies and some of those clusters as well. What do you think?
So Chris, can I chime in, and I'll try and be positive this time? Sorry, but anyway, one thing that emerged from this session that I thought was really good was how context is so important to search or discovery. And I think that was I was implying with my little presentation was that, you know, the scholarly context is only one. And with earth science, as Dave has repeatedly highlighted, we're serving much more diverse contexts. And so is there a use case context is what I'm trying to get at. Is there, you know, maybe the first question that a search system asks is, who are you? I mean, and we've done this sort of thing in the past with sort of like advanced search and novel users and advanced users, but it still assumes a sort of type of user. Whereas, you know, the person that Dave is talking about is very different than the person that Doug is talking about in terms of who they serve. And I just made that up, but you see my point? And I'm wondering if there's a use case, and if this resonates with people, of who are you that is asking for, you know, before we even present you a discovery interface.
Hey, could I say something to follow on that?
Sure, go ahead, Jonathan.
In the coffee hour yesterday, I spoke to a lady from NASA in a heliophysics program, and she was talking about the differences between that program and Earth science program at NASA. And she was describing how scientists spend years working with a data set. So they're very highly specialized data users. And that's like the other extreme of the spectrum. So you definitely want to distinguish that user from, you know, someone who's just Googling, an elementary school student who's Googling for data or looking for a pretty picture. And anyways, yeah, I think that we're on to something.
Well, so yeah, that triggers me, Jonathan. So in this concept of usage-based discovery, show me the data sets that were used in a high school science classroom. Show me the data sets that were used to inform a water management decision. So those questions lead you to, they imply at least a user. You know, the first one is presumably a teacher. The second one presumably is a water manager, or, you know, a regional decision maker. I'm just thinking out loud here, but I like this concept of your designated community, and your designated community is very dynamic. Is, I think, something to really tease out.
Right, and Peter points out that GCIS and the NCA are also another really good use case. And actually the nice thing about GCIS is they have a massive graph, which is linking all kinds of different things, you know, data sets to findings, publications. So I've always wanted to get my hands on that graph database for usage-based discovery.
You know, the comment that Mark was making just now reminded me that the designated communities like that would be very relevant to what Cindy Hall was talking about earlier in terms of creating the data set pathfinders.
Right, right. I feel like if we got the right use case, we could get almost all of the participants, you know, in today's discussions involved in it in some way. I just hesitate to bring one up because I know that people are going to say, no, I want to do this other way. Like, for instance, just as a for instance, you know, right now there's a massive atmospheric river hitting North California, which has a lot of stuff related to it. So you've got massive snowfall, you know, up in the mountains there. You've got rains, you've got burn scars where, for instance, near Santa Cruz, they've had burns recently. There was a whole massive wildfires there. And so now you've got danger of landslides and mudslides. And so there's a lot of potential. I mean, it feels like it touches many of the clusters here, although I don't know if it touches all of them. But I'm wondering if, you know, would something like that be interesting? The thing about an atmospheric river, for instance, is that you could bring in different types of users for different aspects of that phenomenon. So, you know, you could have students who are just studying what is an atmospheric river, because it's a little bit novel, you know, to most of the students out there. They may have heard of hurricanes and stuff like that. Atmospheric rivers are, you know, those have kind of come to the news fairly recently. Whereas, definitely in terms of disaster recovery, there's going to be some serious disaster recovery probably in the next few days from what's hitting there now. Not to mention everything that happened with the wildfires and everything. Or we could find another phenomenon.
That's an interesting concept you brought up, Christopher. Not only have we been showing examples of how you tie certain phenomena to certain data sets, but you are pointing to how there are consequential elements that occur due to a phenomenon, that other phenomena are an inevitable occurrence as a result of that. And so there's a stage of things that happen when certain types of weather hit or an earthquake hits or whatnot, and it makes you think that those maybe should be all connected in some kind of orderly fashion or some branching fashion.
Yeah, that's actually a really interesting point, Rob, about the different stages. That hadn't occurred to me, but you could. So what we could have is a kind of it's more like a use case cluster in this case. I'm thinking now where, maybe it centers around a particular phenomenon. And again, I'll just pick atmospheric rivers as one that has a lot of sort of branches, if you will. And you can look at the educational aspects of it. You can look at the applications. You can look at the science research aspect. And then at the same time, you can look at how it interacts with different types of users, as well as, how it interacts with those different types of users at different stages of the phenomenon, both before, during, and afterwards.
Chris, this is Dave. If as you talk about that, if you come up with one phenomenon and then you have everybody contributing what kind of data sets could support perhaps research in this area, what could support the movement of COVID medical, vaccines on the highways, and what's going to delay them and all that stuff, and people come up with all their ideas. If we can capture that, then that can be applied as a use case and a focused search on data sets that support those activities. Then you might be able to easily replicate that use case in others. It reminds me of a project I was on. I don't know, it was probably 15 years ago, with a big defense contractor trying to come up with a concept to sell the military. And that was a huge 20 million picture workstation that had a programmable interface that you just touched the phenomenon, and you touched hurricane. And once you touched hurricane, this other monitor would light up with all the data sets that you could just touch and display on the screen that could be useful for your decision making. So it kind of seems like this is a similar kind of approach.
Right, yeah. I see Peter's warning us about the highly integrated use case. And I guess that is something to worry about. I was thinking of this as more of a bundle of related use cases, where you could pull out any thread as a single use case and work that. And I don't think you need to integrate them all, everything to everything. Ultimately, eventually, if we do connect everything via, let's say, a graph, for instance, I think you get an emergent integration out of that. But that's kind of purely speculative. It's difficult to predict any emergent outcome, just by its very nature.
So Chris, you're correct. Well done.
And I have to admit, I'm a big fan of emergent phenomena, and particularly with respect to complex adaptive systems. And so I've been kind of dying for an opportunity to really apply it, not just at the computer system level, but also at the sort of community person cluster interaction level.
Would a first step in terms of getting data repositories to kind of pitch in to this kind of mapping to be for them to recount the types of data that they offer and put keywords on it that maybe could apply in terms of like saying it's this kind of data, or it might apply to this kind of phenomenon, and basically just establish a stack of keywords that could be matched into for integration mapping.
I think that would be a part of the solution. I think one thing we need to do is just to figure out all of the entities we need to worry about. So there are the data sets, there's the tools, there are the services, there's the use case, there are the people and the different roles of those people in the use case. I think we also want to consider, but the provider people are going to be considerably different from the consumer people, for instance. And so what I'm thinking is that first we do have to settle on something. And I think what we might do is put out a poll on like 2 or 3 ideas to the potential collaborating clusters, and see which ones they would be willing to cooperate with. And
Hey,
I'll
Chris?
take Jonathan.
Yeah, I think we should have some rules around it, around the use cases. One should be that they're not hypothetical, that they're ground in reality.
Right.
So we can actually interview the people who are involved and ask them, what they value, what data they use for what purpose.
Mm-hmm.
That's I think what really distinguishes us from like purely descriptive or ontology approach where we're just mapping out a hypothetical scope of then relationships between concepts.
Right. So I think we want a real use case in real life with eventually, real people associated with it and real data sets and real services. In other words, I think it's time to get down to the instances. We've done a lot of talking about the class stuff and the theoretical aspect, and now is the time to really get to the instances. So now is the time to instantiate that graph. And I think we might have to end there. We've gone over time.
Just a smidge. I wanted to.
You tied that up nicely.
That's right. Very full circle.
All right. So I want to thank everybody for participating. This has been really useful, definitely from the usage-based discovery cluster standpoint. I hope it's been as useful to the other clusters. Thank you all for participating, especially the folks that gave cluster talks. And what we will try to do is to try to push this forward via this idea of a use case cluster. I guess it's a use case bundle, I'm going to call it, related around some real life phenomena with real things in it. So thanks, everybody. Have a great happy hour. Are we doing happy hour today?
Research showcase. You want to call it a happy hour?
I will call
I'm
it.
not going to stop you.
All right. Thank you. Thank you very much, everybody.
Thanks, everybody. Thank you.
Thank you.